Hello, everyone. Today, we'll be presenting our project, Hyperparameter Tuning as a Service, which is our project for data center scale computing. My name is Aditya Chandra. Today, we'll be talking on our project goals, software and hardware components, architectural diagram, project demonstration, debug strategy, and key takeaways. Project goal. Let's say that, like you're working on some ACL deadline or a paper deadline. And as a deep learning researcher myself, you would like to test some of your experiments on a particular model, let's say, by using different combinations of hyperparameters. But that takes a lot of time because each one of these processes has to be done sequentially. Imagine if you have a service that can run all of these different experiments parallelly, and finally you can report your analysis on these results. That's what we're trying to get at over here. We would like to provide a convenient way to fine-tune a chosen deep learning model on various hyperparameters for our users. So what do the users need to provide? They upload a custom data set, select a pre-trained language model. So we are choosing Hugging Face API for that. And they select a combination of hyperparameters that they want to fine-tune on, download the best performing model for a given set, or any model which they want to further make some ablation studies on. So what we are building a simple user-friendly UI for this, and we're using RESTful APIs. So some of the software components, we have Docker, Kubernetes, Flask, REST API services, React JS library, Google Cloud logging, Kafka message queues on Confluent Cloud, MongoDB database on AWS, Redis in-memory key value store, MinIO, and PyTorch deep learning framework, and Hugging Face APIs.
All right, quickly going through our hardware components. We are using Google's Kubernetes cluster, which has provisioned GPUs. We also using Kafka, which is hosted on Confluent Cloud. Our MongoDB is hosted on AWS Atlas. And we are also using Google Memory Store for Redis. And our MinIO storage is also hosted on Kubernetes. And for our testing and development purposes, we use Google Colab. Now we'll quickly go through the demo of our project. So our application is currently launched in Kubernetes. First, we'll land on our login page. So here, the user needs to use OAuth to sign in. So once the user signs in, as you can see, the first page is running. And here, no jobs are currently running, which is why we say no data is found. So first, let's try and add a job. So the user can click this button. We'll try to add a job. So let's try and give an experiment name. We'll call it classification testing. And then let's choose sentiment classification. Let's say the model is, we want to choose this Distal Roberta, and the user has to upload training data sets. Once the data sets are uploaded, we can choose the learning rates that we want to provide. Let's say I want to test it with 2 different learning rates, and I'm interested in testing with just one value of weight decay. Let me keep my batch size as 4. Warm-up steps can be around 50, and max epochs, let it be around 4. And once all the hyperparameters is decided, we can choose to add job. So as our backend starts to pick up each job, we can see in our running page that the jobs gets populated, and we can see the status as running.
All right, so now we can see that the jobs are running, the experiments are currently running, and the status is in the running state. Now let's take a look at the architecture diagram of the entire step that we just now did. So here we have the users using their UI web client, and they're going to get into the Node.js server frontend. And then once they get into the front end, they're going to be talking with the front end is going to be talking with the REST services that we have written. And then this REST service is going to input all the information into the Kafka message queue and also write to Redis. And the data is going to be shared on MinIO. And once that is all done, we have this logical layer, which is our trainer service that we have built. That is the, as you remember, we selected certain Hugging Face models. We selected different parameters separated by comma-separated values. All these different values are now going to be run in this logical layer over here. And over here, we have written a service that is going to use Hugging Face pre-trained models. It's going to download them into the service. And then once it's downloaded, with the different hyperparameters in mind, it is going to train all the different models concurrently. So this is the whole task, right? We were talking about this in the beginning, saying that, okay, we have a deadline in mind and we want to run all these different hyperparameters one after the other. If we were to run this sequentially, it would take a very large time. But now what we are doing is we are going to run all of them concurrently, and our front end is going to give us what are the final results that we're going to have. So that's, again, the logical layer is going to talk with Minayo, right, again to Kafka. And then the backend is going to say that, okay, now I have the message queue is done. We will see a completed job shortly. And once all the training is done and the message queue gets the information, then we can display at the front end.
All right. Now that we've built this amazing service that can actually save us a lot of time and also come up with a better analysis on different experiments, we always need to make sure that we have valid debugging as well as testing scripts so that we run a clean code and also handle all types of faults, right? So basically, what are we using? So in our Flask service, we are running it on built-in debugger, and we are using Kubernetes cluster logging. We also written multiple unit test cases for individual microservices. We also run local testing via Kubernetes engine or by Docker Desktop. Event-driven message loggers have also been implemented. And finally, for our trainer service, we also have model training evaluation tests so that we don't induce bad experiment practices. So what are our key takeaways or learnings from this project that we have done? Developing modular applications helps in multiple ways, right? So what we did, so we separated our model training service, backend service, and UI service. We deployed our microservices to Kubernetes, which is wonderful for orchestrating our deployments and managing it and scaling it, right? We learned multiple Kubernetes components like deployment services, config sets, secrets, and ingress, handling large file uploads, because when you're trying to train certain models, you require huge data sets. So we use chunking for that and batch process the data set. Managing multiple REST API payload formats, because we have files, huge files, we have JSONs, we have inputs, right? Like learning rates or other hyperparameters. Training Hugging Face models at large scale was another important key takeaway.
So finally, now let's just see if all our models have been trained. So let's go back to the homepage, and as you can see, there you go. All the different models have been trained. As in our case, we have given 2 different learning rates. So those 2 different variation of the models have been trained. And here are your learning rate, the weight decay, batch size, maximum epochs, number of steps. And then you can also click on the download button to basically get the model files into your desktop.
Thank you.